All right, we got numbers 2, 4, 5, 8, 10, 12, and 13. It's a lot. Let's do it. All right, so we got to change these. We got to solve, right? We're solving for b. Okay? To solve for b, I need logarithms because b is an exponent. But before I can put it into exponential form, I need to get it, or before I can put it in logarithmic form, I need it in exponential form, right? I need it to look like a base raised to the exponent is equal to a number, right? And from there, we're going to make a log of a base, right, of a number is equal to the exponent. That's all we're doing. So we're going to use basic algebra first. Okay? If this is my exponential function, right, I'm going to move the 6. How do I move the 6? I do the opposite. It's negative 6 times 10, right? So what's the opposite of times? Okay? It's that simple. Now, I'm going to have this as 10 to the negative 9b is equal to negative 87.9 over negative 6. Now, from there, I put it in base form to log form. Log base 10 of the number negative 87.9 divided by, so there are two negatives, I'm just going to get rid of the negatives. 87.9 divided by 6, okay, is equal to the exponent, negative 9b. Now, what do I do to get b by itself? The opposite. What's the opposite of times? Divide. So I'm dividing by negative 9, I'm dividing by negative 9. When I rewrite this, remember, log base 10 of a is equal to log of a. It's just like I wouldn't write the square root of 8, right? I would write the square root of 8. I don't need that 2. If it were a 3, I'd keep it. If it were a 5, I'd keep it. But it's a 2. It's a square root. Okay? So same here. Base 10 logs. That's what we use in our calculator. So we don't use the 10. So when I rewrite it, I write it without the 10. So it's going to be log of 87.9 divided by 6 all over negative 9. That's what equals b. Okay? And then I just take it in my calculator. Okay? And I do log 87.9 divided by 6 and in the parentheses. And then I divide it by negative 9. And it equals, I get negative 0.1295. That's what b is. I want both of these answers. Okay? Alright, the next problem. A little harder. Okay? So, doing the same thing though. What's the opposite of add 8? There we go. Okay, so I got 11 to the v minus 10 is equal to, well, 83 minus 8. What's that, 74? No, 75? Okay, so now I've got exponential form, log form. Log base 11 of the number 75 is equal to v minus 10. Now log 11 is not log 10. So I need a rule. Log base b of a is equal to log of a divided by log of b. Okay? So, this has to be changed. Log of 75 divided by log of 11 is equal to v minus 10. Now what do I do? Yes, ma'am.
How do you know which one's like log B and log
What do you mean?
B? Like that.
The base is b.
Oh, no.
The base. So they use b always as a base. So like the base is 11. And it's really simple, just go like this. Draw the line, draw the log. Okay? Keep it easy. Okay? Now, what do I have to do to get v alone? Add 10, right? And I add 10 to this. So I have log of 75 divided by log of 11 plus 10. Now the cool part is, in our calculator, we don't have to put parentheses around this, right? Because it does the division first, right? PEMDAS, parentheses, exponent. Multiplication, division first, then addition, subtraction. So, I can plug in log 75 in the parentheses divided by log 11 in the parentheses and then add 10. And that should equal 11.8005. And that's what V is. And that's, I want both answers. Okay? So, this math gets as hard on doing the calculator work as it is doing the actual work. Okay? Next. Alright, what do I got to do when I subtract 10? What's the opposite of subtracting 10? That's it. Okay? So, I'm going to add 10, I'm going to add 10. So I get 10 raised to the 7x minus 5 is equal to 72.4. Now what do I do? Logarithm, right? Log base 10. Do I need to write it? No, it's a base 10. Of a number. Well, 72.4 is equal to what? 7x minus 5. Now, what do I do? I add 5. I add 5. So I'm going to rewrite that as log 72.4, right? Plus 5. So get used to writing those parentheses. Okay? Plus 5 is equal to 7x. Now, what do I do? What's the opposite of times by 7? Divide. Okay? So, log of 72.4 plus 5. This should be in parentheses because I need to add before I divide. Divided by 7. When I plug that into my calculator, I should get a number. So, clear. Now I have log 72.4 in parentheses plus 5. Okay? In parentheses. So I don't even think I did a parenthesis. So I'm just going to hit equals. Right? Now I'm going to divide by 5. Equals 1.3719. Then I check that with my answers. Uh-oh, that's not right. Is this 5?
Yeah.
Let's try that again. Log of 72.4 equals plus 5 equals divided by 7 equals, haha, 0.9799. I think it's going to make a 0.98. Okay? Is that right? Perfect. Okay? Oops. Not that part. That part. Okay. Pin is going away. Good? Alright, let's run over to the other side. Woo. Holy cannoli. Holy roller, Batman. Alright, 8. 8, what you should realize is as you go through this worksheet, it gets easier. Okay? Not harder, like a lot of worksheets. Okay? So let's look at 8. 4 to some power is equal to 1 over 64. So think about that. That means that that power has to be negative in order to make this not a 4, but a 1/4. So how many 4s do I need to multiply to get to 64? Well, what's 4 times 4? Is that 64? No, that's 16. Okay, times another 4. What's that?
Oh, 4 or 3 4s.
Yes, 3 4s. 4 times 4 times 4. That's going to give me the answer. It's going to take 3 4s, but negative exponent. It's a negative exponent because it's flipping it. So anytime it flips it, right? Anytime it flips, it's negative. Okay? Now in this case, how many 4s make 64? Well, we just said it's 3. It's just this case it didn't flip it. Does that make sense? And that's easy. That's done. Those two are done. Okay? Next. Now we're going to condense these. Wait. Is that what we're doing? Yeah. We're going to condense these. Okay? To condense them, this one's a little harder. They're kind of messing with you. Okay? Let's rewrite this one. It's 3 log base 3 W plus 1/3 log base 3 of W. Right? This is easier. Believe me. Because guess what I can do? The rule is, right, the power rule says, hey, if I've got x times log base b of a, then that equals log base b of a to the x. That's the power rule. Okay? If I have log base b of a, let's just say log of a plus log of b, then that would equal log of ab. Okay? They times. If I have log of a minus log of b, then that equals log of a divided by b. They divide. So those are our rules. Power, product, quotient. Okay? But those are our rules. Quick, easy. We should have those in our notes already. Okay? Next, so that means that I can take this and make it a power. So it's log base 3 of W to the 3rd. And this one is log, are they both just W's? Did I copy this right? Or is one of them a U? I thought one of them was a U. Yeah, this is a U, not a W. That's a U. Okay? Alright, so, and then this one is U, so plus log base 3 of U to the 1/3. Okay? So, because these are two different bases, when I multiply, right, I can't just add the exponents. I actually have to just put them together. So what happens is I get the log base 3 of W cubed, times u to the 1/3. And then what your book wants you to do, or what this wants you to do, is realize that 1/3 is log cube, or log base 3 of w cubed of the cube root of u. And that's your answer. So remember, when you have a 1/3 exponent, that's really a cubed root. Okay? Now this was a little easier because I just take my rule, 6, and put it as a power. Log base 3 of 2 to the 6th plus log base 3 of 5 to the 4th. Right? I'm just taking this and making it a power. And then this addition sign right here, I'm going to make that into multiplication. Log base 3 of 2 to the 6th times 5 to the 4th. And you can make that a big number if you want, but you can keep it like that too. Ta-da! That's it. Done. Should be getting a little easier.